Hey there, it's Zach. Today we'll be using the Amazon Web Services SageMaker service, and we will create a machine learning model with the random cut forest algorithm, and then we're going to test it. So first, if you do not have one and you want to follow along, you're going to need to create an AWS console account. After that, you will go into Amazon SageMaker, go to Notebook Instances. I have one running, but you will create a notebook instance. You can just create a name and leave everything else as is and create it. So that's going to be pending for a couple of minutes. Once it's done, you will click Open Jupyter. I have mine open now. You will click SageMaker Examples. What we are going to be using is the random cut forest. So click Use and click Create Copy. The change you're going to want to make is within the S3 bucket, this change right here, if you want to pause. So it's going to be these 5 lines. Make that change, save, and run all. This will take a while, so I have one queued up. So what is this? It is the AWS SageMaker random cut forest algorithm. For those that don't know, a brief overview of machine learning is these 7 steps. It's collecting the data, preparing the data, exploring, training an algorithm, then testing it, evaluating the algorithm, and then improving it. Here, what we're going to do is we're going to be focusing mainly on these 4 topics. We're going to have a pre-existing set of data about New York City taxi rides. We're going to train the algorithm, test the algorithm, and then evaluate it. And random cut forest has to do with the concept of if all these dots are graphed, how many slices would it take to isolate it? So as you can see, this first slice in node C is 1 slice in. And if we make another slice, then D becomes isolated. That's 3 levels down. A 4th slice, G would be isolated, and a 5th slice would isolate J and H. If we had a plot over here on the graph, it would only take 1. And what this is used for, it's used for detecting anomalies. So whenever you have some sort of data that you need to see the anomalous function of it, that's when you'll run through the random cut forest. So let's take a look. This is mostly automatic. What it will do is it'll load up all the code that it needs and it will create a bucket, but we're not going to worry about any of that. So as you can see here, somewhere in the 5900 range, you can see this huge line and maybe a couple over here. And so what we're trying to do is we're trying to see of the taxi rides every day, which is an outlier or an anomaly. So as you can see here, the 5954, it's 39,000, and then there's a 35,000. So obviously that's pretty crazy, but if we had large data sets with millions of numbers spanning years, we don't have to graph this out and look at it by hand. So what we do is we train a model. I could spend, make a 72-hour video describing hyperparameters and training of a model. But just know what it's going to do is it's going to train itself off of test data provided. And using this algorithm, scrolling down some more, we are going to see some computations for these anomaly scores, right? So as you can see, 10,000, the score's 0.94 because of its relevance and its relation to the numbers closest to it. So here you can see the anomaly scores we were referring to. You can see 1, 2, 3, 4. Those 4 look pretty anomalous, just in comparison to the ones located near it, because as you can tell, during the time of the day or during seasons, usage and different numbers will kind of evolve and change over time. But this is definitely an outlier. So scrolling down, this is where the algorithm really kicks in, is it has these identifications of these anomalies. Let's keep scrolling. So these clustered anomalies here, this is more of a grouping of, as you can see, of the taxi ridership. So what you could do is you could put through years of this data if you were in charge of scheduling taxis, and you could try to estimate when there would be surges. One of the benefits of anomaly detection is if it's a true anomaly per an algorithm, which these are, you could absolutely, if you wanted, just take it out of the data set. And that way in the future, if you're making estimations, it won't be skewed by said anomalies. There's a lot of different uses for this. I probably won't get into it too much. What I wanted to do is kind of explain the ability to quickly use this Amazon SageMaker. Why is this useful? Well, it provides the service and the backbone, so you could just have a high-level understanding of machine learning and still apply your own data set without having to be a software developer and data scientist like me. You could just bring in your data set up near the top of this script and manually upload the file. It's pretty crazy, right? And this would be the end. And as you can see, it uses pretty common layman terms. This is deleting the information after. Now, if you're following along, keep in mind, again, this will take a very long time to run through just because it's so computationally heavy. I'd have to guess it would be 10 to 15 minutes through the entire process. And once that is done, the most important part is stopping these services. I say that because I have received a $500 bill, and it's not very fun. So I will be making more of these videos on different algorithms and deeper dive into different aspects of machine learning, artificial intelligence, and deep learning. So if you have any questions, just feel free to let me know. Thanks.